This is known as Euler's identity. It connects e, pi, I, 0, and 1 all into one equation. This is e. We find it by taking a very tiny infinitesimal interest rate, so small, as close to 0 as you can, and then get smaller. And then we compound that tiny interest rate an infinite number of times. And we call that number e, and it's approximately 2.71828. Pi is defined as the circumference over the diameter. So if we have a circle and the radius is 1, the distance halfway around the circle would have a length of pi. Next up, let's talk about I. It is called the imaginary number. It's defined as the square root of -1. Since it's imaginary, it can't be expressed on the real number line. So we have to give it its own axis. If the number 1 is located right here on the real axis, then I would be located here on the imaginary axis. And if we square both sides of this equation, the square root and the 2 cancel each other out. So we're left with I squared equals -1. 0 has a cool property. When it is an exponent, any real number to the 0 power is equal to 1. 1 is the multiplicative identity, meaning 1 times any number, real or imaginary, is that number. We know e is approximately 2.718, so it would show up around here. If we multiplied e by itself, we would get approximately 7.389. Another way to express that would be e squared, and e squared plots to about here. Anytime you take an exponent of a real number, if it moves you along the real axis. Now let's look at operations with imaginary numbers. If we take our e to the 0 and multiply it by I, what does that give us? Any real number to the 0 exponent is equal to 1. Well, e is a real number, so e to the 0 is equal to 1. Anything times 1 is itself, so we can conclude e to the 0 times I equals I. Since e to the 0 is 1, it would be plotted right here. And since e to the 0 times I is I, it would be plotted right here. How did we get from here to here? Well, we rotated by 90 degrees. Multiplying by I always rotates us by 90 degrees. Let's do it one more time. If we take I and multiply that by I, it gives us I squared. And from up above, we know that I squared is equal to -1. -1 is right here, so e to the 0 times I is right here. Well, how did we get there? It was another rotation of 90 degrees. E to the I power is also a rotation. If we use a fancy calculator, we find out e to the I is approximately this, and we can plot that right here. If we look at e to the I, we can rewrite it as e to the 0 plus I. So anytime you're adding exponents, you can split it up. So we can rewrite this as e to the 0 times e to the I. And let's change this I to a 1i. So if we start at e, this e to the 0 piece moves us along the x-axis over to 1. And then this e to the I piece rotates us to this point here. And to find out the distance that it rotates us, we can do a little bit of trigonometry and find out that it's 1. The distance that's traveled here is 1. Notice all the 1's right here. That is not a coincidence. The coefficient for the I and the exponent of the e is the length of the arc that we travel when we do the rotation. So if we change that 1 into a pi, this rotation is going to travel a distance of pi. It will be a circle of radius 1. After we travel the distance of pi, half the circle, that brings us to -1. So e to the pi I is equal to -1. If we add 1 to both sides, we get e to the pi I plus 1 equals 0, and we can swap these two